Hello, welcome to this short presentation, little video, one of a series of Petzl talks, and where we're going to discuss in this episode aging and lifetime of Petzl PPE. So some questions that we're going to look at. What are our recommendations concerning lifetime of PPE? Metal, textile and plastics, the factors which affect their aging. We're going to look at how Petzl tests, in fact, for aging of PPE artificially in a laboratory, and then what can we suggest to help your PPE last a little bit longer. To begin with then, what are Petzl's PPE lifetimes? Well, it's down to the manufacturer to indicate a suitable lifetime. We have an obligation to indicate a suitable maximum lifetime. There's often talk of planned obsolescence. We hear talk of this more and more these days, related to manufacturers' lifetimes. But you can rest assured, we know that you want to keep your PPE in use for as long as possible and obviously have your safety in mind. So making sure that you can use your PPE as long as possible in complete safety is our daily concern. Right, let's have a look at Petzl's indicated lifetimes then. For metallic products, it's unlimited. For textile and plastic products, 10 years. And for mixed materials, it's the same. Unlimited for the metallic component, 10 years for the textile part. For metallic products then, the lifetime is unlimited. So a protraction such as this one, structurally metallic components, unlimited lifetime. If I was to take a textile or a plastic product, so harnesses or helmets, example such as this sports climbing harness, then I've got principally textile manufacture, 10-year lifetime, 10-year maximum lifetime. And where we have mixed materials, it's the same principle. So here with a Grion lanyard, I have a metallic component also combined with a removable textile component, then 10-year lifetime for the textile, unlimited lifetime for the metallic component. In order to clarify the lifetime of some of our products, which are often considered to be structurally made of metal, but have plastic components as well, then it's good to just look at the technical instructions. All our technical instructions explain clearly whether it's a 10-year lifetime or maximum indefinite lifetime. Examples of such are like the rig here with a plastic handle. For sure it's a plastic component that allows us to complete certain actions, descending, belaying, hauling and so on, but the structural elements to the rig descender, the axle here, and the cam, which are the structural, the main mechanical elements, are metallic. Likewise, for the Petzl Maestro, it's the same principle, the ID and the gree as well. For Petzl, the beginning of the product's lifetime is the date of manufacture. So we're going to look at that in more detail right now. We can see here a little table as how the date of manufacture for Petzl's product has been marked and also how it's evolved over the years. So you might find examples of these different types of marking as you look at different Petzl products. Now, we talked there about the manufacturing date. Why doesn't Petzl include a storage time in their overall lifetime? Many other manufacturers do that and we don't. Well, let's look at a couple of reasons why not. Storage times are really quite variable, and that doesn't enable a very simple time scale. There's 4 variables that we need to look at there. First is how long is the product in stock before distribution, so between manufacture and it being distributed. Then, secondly, the time on the shelf before the product's been sold to an end user. Thirdly, does the end user or the company that's bought the product put the product into stock or not? And how long do they store it for? And finally, there might well be varying lengths of period between uses of the storage. So a product is being stored and used multiple times. How do we manage that? The conditions that the product's stored in can also vary. And we're looking there at temperature, humidity, UV light or indoor lighting and so on. All of which, as a consequence, means the only real reference point we've got left is the date of manufacture. And for that reason, at Petzl, we stick currently with the date of manufacture. But let's not forget that in any case, any item of PPE might well need to be retired at or during its first use as a result of a fall, for example, but it could be overloading, heavy loads, it might be damage through abrasion during its first use and so on. It may be that we have 6 months of use, depending on conditions, maybe 10 years of infrequent use and we arrive at its maximum. It may even, of course, be where current work standards or practices evolve and change, which renders using that PPE obsolete. So there are different variables. Obviously, we're not always going to get that maximum unlimited lifetime for metallic product or 10 years for textile. But to get a better understanding of the lifetime of our PPE and also how to take care of it, we're going to look at some factors which contribute to aging. And this is really the main content of this short video. All of our PPE is split then into two families. Those which are manufactured principally in metal, so what I mean by that is the structural components are metallic. If we look at the protraction, we've certainly got nylon, polyamide components as well, but the structural elements to this product are all metallic. And then we have a second family where we're really looking at the majority of the product manufactured in polymers or using polymers, so plastics for helmets, textiles for harnesses and ropes and lanyards and so on. For sure, we can see we've got metallic components, but the structural elements of this harness are textile. So different factors affecting aging for metal and polymer based product. The first thing we'll deal with is corrosion. So we're going to look at metallic product. Metals oxidize. They all do. That's what happens with metal. And this reaction is a chemical reaction, and it's accelerated if we mix water and air together. So really water, H2O, and oxygen. Mixing those two together will lead to oxidization, especially if water is salty. Just as a side point, the concentration of salt in seawater is exactly the right amount for the fastest rate of corrosion in the majority of metals. So it's not only due to water in its liquid form, something like sea fog or sea fret, where we have a high concentration of salt in a marine environment, is also highly corrosive and will accelerate oxidation. Simply, we're going to look at two types of corrosion. So we have visible corrosion and invisible corrosion. Visible corrosion, in this case we can see, there's a photograph here, we can see a corrosion which might be just a few small surface marks easily cleaned off, or maybe more significant corrosion. So by carrying out a thorough inspection of your PPE, that's going to allow you to decide whether you can continue to use it or not. Invisible corrosion also exists. This type of corrosion will attack material, we'd say, from the interior, from the inside, but particularly for metals under stress. And this is what we can't see. This can result in fractures without any apparent warning, and we see this and we refer to this as stress corrosion cracking. So a few tips to protect against corrosion. What can we do? Well, first off, selecting appropriate PPE which is adapted and designed for the environment. It may be manufacturing different types of materials which are more or less corrosion resistant. Rinsing your items in fresh water. Anything which has been exposed to salt air and salt water, give it a rinse in fresh water, soft water, then we're removing that salt from the equation. Drying personal protective equipment before storing it, so making sure that we store away from humidity, but first off, making sure the equipment is dry before we store it. Avoid exposing PPE to the humidity, perhaps of dew in an early morning if we're then going to keep it wet during the day. It could be an advantage as well. And being particularly vigilant where we're using PPE which is under constant stress and in humid conditions. And there's been many examples of this over the past years, and we know more now about stress corrosion cracking, but where we are loading items in humid conditions and keeping them under stress, be very vigilant. Another topic, repeated loadings. So with the effect of repeated loadings, metal can suffer from what's known as fatigue. This is exactly what happens if we were to repeatedly bend a paper clip. So if we take a small paper clip, thin wire paper clip, repeatedly bend it, we've all seen the effect. Eventually it leads to failure. In the case of PPE though, this is much more complex. Multiple pieces, many different shapes, different materials, they're all interacting with one another, and therefore we need to take the whole structure of an item into account. It's not just a single component. As a result of these repeated loadings, we can propagate micro cracks, very small cracks. So breaking of steel springs perhaps in moving parts like descender handles or carabiner gates, and it's for this reason we've equipped ourselves here in Petzl over the years with specific machines and specific test protocols. We've been able to construct a database, and that database has the aim of anticipating and avoiding consequences of aging, but that's theoretical. This is the sort of thing that we do every day by testing the aging of every different material and every different product that we have in development. And because this type of aging is absolutely inevitable, we then take big margins in the conception process to avoid after effects in use. What about abrasion? Abrasion, in fact, concerns both metallic items and textile or plastics. Abrasion is something we're exposed to all the time. Here's how we test our products for abrasion resistance. We've got a little bit of a film of a machine that we're using here, but it can occur due to three different reasons. It might well be against aggressive surfaces, for example, rock, concrete, trees, sharp edges. It may be I-beams, structural steelwork, a sharp flake of rock. Thirdly, it might well be against another item of PPE. So it could be a connector, a rope or a sling which rubs against another element of the same item of PPE, leg loops on a harness, textile against textile. So some tips here to help survive the effects of abrasion. Protect your PPE against aggressive surfaces, rock and concrete, trees and edges. Make sure that your PPE is protected against those. Look out for potential abrasion points between different items of PPE that are being used together, or maybe different elements of the same item of PPE. Protect ropes from dust. Sand and so on can make them very abrasive, and these particles can also be responsible for accelerated internal aging by damaging non-visible fibres, for example on the inside of a rope or a tubular sling. If possible, protect your ropes also against ice and freezing. We know that's not always possible for sure, but ice crystals within the structure of a rope can also be abrasive. That obviously will go off when the ice melts, but in that period it can be a hazard. Now, I'm going to look at something a little bit more scientific, polymer degradation. What do we mean by that? Well, all helmets, ropes, harnesses and slings are made from textiles or plastics, and all of that comes from polymers. Polymers can be particularly static, such as Dyneema, or they might have a certain elasticity. It depends on the makeup of the element. But in any case, over time, all polymers age, and this is inevitable. The degradation is completely natural. In fact, if we look at how polymers are made, it's a chemical assembly of thousands of different molecules, all with different links between them. And it's this assemblies of molecules that make it possible, for example, to manufacture synthetic fibres, so long chain polymers. As soon as they've been assembled though, these molecules tend to want to regain their independence, and the links between them gradually degrade. And as a result, the raw polymer starts to degrade immediately as soon as it's produced, and there's nothing we can do to prevent that. The natural degradation can also be accelerated though by several factors, and this is where we can have an effect. So heat, light, both of these provide energy that can speed up the degradation of polymers. And this is why we test our textile and plastic PPE in some climatic chambers, and we can often bring those to 80 degrees centigrade, which allows us to highlight certain phenomena such as the release of stresses stored in a plastic component during its manufacture. In the case of light though, it's a little bit different. It's ultraviolet rays that are involved, and being more specific even still, the most harmful ultraviolet rays are UVB, just the same as it is for sunburn when you're outside and not protected. Whatever the location, the solar spectrum is the same. But on the other hand, the intensity of light can change according to your location, the season, altitude, or the weather, obviously, if it's cloud covered or you've got a nice clear sky day. So whenever the sun could burn your skin, then PPE is also going to age prematurely. So what we do here is we test the behavior of all our different elements of PPE when they've been subjected to UV light in the laboratory, but also under natural outdoor conditions. So we test them, helmets which have been stored outdoors, for example, as well as those which have been exposed to artificial UV radiation. As I've done before, let's have a look at a few tips to help you protect PPE from heat and UV aging. Well, avoid leaving your PPE in place outdoors as much as possible. Store equipment away from light and heat. It can be very hot in summer in some storage areas. Avoid leaving a helmet, for example, on the parcel shelf or the dashboard of a vehicle. We've measured temperatures of over 70 degrees centigrade. In case of longer exposure, though, in certain geographical areas, which is necessary for a work task or for expedition use, for example, in high mountains or deserts, then you can be certain that your PPE will have undergone an unusual and accelerated aging process. It's normal. Some last words of advice. In order to keep track of your PPE for as long as possible, don't hesitate to use some of the support that's available for you. Product instructions and information for sure. Petzl's PPE inspection forms for each product give a good guidance of what to look for and what might be deteriorating. We have a guide for maintaining your PPE. It's available on petzl.com on each product page. You can download all these documents from the website, in fact. We also have training modules that are available throughout the world, giving information in how to check PPE. Finally, perhaps most importantly, make sure you do go ahead and check that PPE before use, during and afterwards. They're kind of some of the basic principles of using this type of equipment. So, as a conclusion, a product should be taken out of service if it's a plastic or textile construction and it's more than 10 years old. If it's suffered a significant fall or an overload, if the result of any PPE inspection is to reject, it needs taking out of service obviously. If you've got a doubt about its reliability, if you don't know the complete history of its use. Also, if its use is becoming obsolete, and that might be through legislation reasons, it could be normative standards, it might be technical evolutions, or maybe even an incompatibility with other equipment in the system. These products would need destroying. Take them out of use and make sure they can't be used again, and potentially recycled much of this equipment. For manufacturers other than Petzl, then the lifetime always needs to be indicated in their instructions for use. They've got the same responsibilities as we have, so check instructions for use to give you more information about product lifetime. That's all we have time for in this short Petzl Talks, so thanks very much for your attention, and we'll see you next time.